This is a project I started a while ago and then kind of ended up stalling out. Raspberry Pi 3 with the first revision of the robot. The goal here is not fidelity, right? It's actually the opposite of that. The goal is basically, what's the worst robot that I can design that can still draw pictures using feedback from the tablet? The transistors and resistors, tablet plugs in there. I've done a whole video series on these tablets. They're basically sensing a frequency modulated pressure and button signal that comes in at around 255 kilohertz. So this is made of NinjaFlex. It's flexible. It has room to kind of squish these motors in there. I 3D printed this before, but then I wound this coil yesterday and glued it on. It's all still pretty delicate and pretty lightweight. Now the question is, will the image become intelligible before or after the marker runs out of ink? So as you'd imagine, it's very sensitive to the leveling and the position of the leash and all sorts of other external factors. One nice thing about printing it in NinjaFlex is it does make the pen mount pretty easy. I was having trouble with it just like rotating in place, and then I trimmed the ends a little bit more and managed to correct that. A future version of this should definitely make the bristles adjustable somehow. Yeah, it does need to plan further ahead, I think. Something where it does look in the direction that it's moving and then try, like what if you just cast a ray in that direction and then like add up all the pixels along that ray? Oh yeah, this is the image it was trying to get to. I uploaded the code I've got so far to GitHub. You can also get the CAD designs. These are pretty old. The circuit here is just a Raspberry Pi, 4 transistors, and 5 resistors. The one I'm using is close to this, but yeah, this is part of why I'm getting new motors, is that I don't really have a source for the ones that I'm currently using. This area that it's drawing right now is kind of complicated. I wonder if I can just like drop it in a simpler area and we can get maybe a better idea of how it's doing. That looks all right though. Let's just put it over here. So the blue channel here is just where we've been. The red channel here is just debug. I should add some text to the red channel too. The green channel is the kind of composite image that gives it its current goal. And so you can see it's kind of being eaten away by where the blue line is already. This might be the best RNG we have on the good paper now. Yeah, maybe we'll do the shaded circle next, because it would be nice to know how well shading currently works at all. It's not too bad. Yeah, this does require some leveling. You can see my solution. I've got the tablet on top of these little 3D printed jacks that I can adjust. Honey, just a second. I'm trying to get the robot started. Obviously fell off the page and like messed up a bunch, but clearly shows that triangular stroke, shows the way you can actually see how the triangle changes shape across the page too. A lot of that's probably because of how the wire interacts with the robot. Like this is kind of what you want to see, sort of. Like this is very weak, but ideally you would see this kind of like tri-lobed pattern. So you have numbers over here, and over here, and that would indicate your robot has a choice of going in these 3 different directions. We're not really getting there. So I've been noticing the robot with only 2 of those lobes a lot, which is part of why we end up getting stuck frequently. And none of these choices are even worse. And then we just end up out. All the vectors are pointing up. Ooh, did we get some downward vectors? We got some downward vectors and we're using them, and we actually ended up following pretty much that same path. Let's have a test image. I've got some CAD drawings. Yeah, I think I just need a couple of different blurs combined together. That looks promising so far. Because this seems like it's doing alright, but it might take some time for this one to really become legible. Channels, so red is just debug, green is just the target image, blue is what we've drawn so far. Cool. And so this will gradually get eaten away as we let this run. Oh, it's gonna do the ears now. And it doesn't really even need the brush things. The brushes I thought were going to be useful like when I started designing this, but I think the way it actually moves is mostly about using the vibration motor to kind of scoot the nib across the page. And so I think mostly the vibration motors just need to be on kind of a lever arm that is spaced away from the pen a little bit, and then some kind of little like training wheel leg or something that keeps the pen from falling over. So it's been going for 30 minutes. Now it's 5,800 frames. I wonder how much of a dent we're making in that green channel. Wow. Here's a really fuzzy Tuco head. You can see the strokes it was making around the ear, these kind of triangular back and forths. I think the robot itself was very well balanced while it was printing this, so the strokes were nice and triangular, but the software was running really slowly because this was limited by some bad design decisions at the time, and it was doing a bunch of image processing on the same thread that it was trying to do motor control on, and it was all bad. So, like, these are all right. If the robot could only produce these, then I would still probably think it's a pretty cool project and want to teach people how to build them. But I think it's possible to make stuff that's even more nuanced than this. This one actually worked all right, but mostly by accident, and it's pretty much impossible to adjust. Vibrating mini motor, 2 to 5 volts. All right, here's a motor. Whoa, something like that. I thought about making one that is not 3D printed because it doesn't really need to be 3D printed, and if I could make it simpler, then it'd be easier to put it together. So I thought I'd try making one out of paper. One common lead, 3 motors, and then 1 transmitter coil, which pretends to be the tablet pen. Okay, I think that was about 50 turns. Also might be other wiring options for this, like if it turns out that stiffer wire is fine, then maybe there's some kind of multi-conductor cable that's already in the Adafruit catalog that I can recommend. Oh, that actually flung a little solder ball into my skin. Oh, I see some green. And it's a little hard to tell how well it's tracking given the low update rate of the debug info here, but it looks right. Whoa. What if I do just try to basically make this a pendulum? It just seems like the feet are really important. Like it does need a precise leveling both for the tablet itself and for the robot. the way it's just hanging out over there. It's still not drawing very well, but the vectors are looking better. This is how a little bit of success looks. It's not perfect, but it's kind of working. The pen is now allowed to slide up and down in this tube, which helps the robot stay level on the page, and then the pen provides its own downward pressure. So that was actually really good, but that also completely changes the weight of the robot, because now you don't have the weight of the pen acting as part of the robot weight, and then this is kind of bouncing around without a lot of weight to keep it on the table. So I think actually what I want is a bunch of mass right around the same location as the coil, if I can get it there. Whoa, that's kind of nice. I'm going to try to do this in a non-permanent manner. If the tension is just right, it pushes the page that way. So maybe the thing that the bristle is giving us is a surface that bends more easily. So that works nicely when there's a light contact. Seems like it's one of those things where once we find the right combination of parts that actually work, it should actually be pretty easy to make these and to just, load a couple things on your Raspberry Pi and have it off and drawing. That's kind of what I'm going for. Like, I want to create something else that is easy to build, but interesting because of its imperfection rather than because of its fidelity. Solder does not stick to this tip at all. All right. Whoa. This is great. This is only 1.2 volts also. Can I go any slower? That's a half a volt, and it just scoots right along. Okay, my soldering iron with the sacrificial tip is still hot. Oh, just like watching it settle down, it like wants to move. That's the common, 3 motor joints, and the coil joint. I'm not going to bother using fresh paper for this yet. So 3 volts now. Maybe I'm just not getting enough vibration isolation between the legs now. Part of what was actually really good about this design is that each of the paper clips are separate. Any vibration that goes through this actually first ends up going through this tape joint and then the paper. Now we've mostly just got a lot of wiggling without a lot of moving. Like there still isn't enough weight, maybe? Okay, well, this thing that I did up here kind of negates what I was trying to do with using the paper to separate the vibration between these, but I'm hoping they're still mostly separate. This is like, what, the 4th version of this that I've built this week. It's still pretty unreliable. It's hard to get the thing balanced so that I can reliably move in 3 different directions. I'm coming around to also thinking that the paper clips are a bad idea just because there are too many vibration modes. I think that a flat vibrating structure might be the way to go. There is not very much vibration isolation. Cut. Oh, that is so much better. Okay, cool. Now I can try to balance this again. Whoa. What did I just do? Oh, I broke a paperclip right here. Metal fatigue. The solder isn't going to be great, but let's see if it's enough. Zoom! It's not great, but we do have 3 directions there. That one goes the right direction when I put some weight on it. Maybe we do just need more weight on the legs. Oh yeah, that's moving in the right direction. Whoa. Running out of ideas for improving this design. I think the tunability of the paperclip is deceptive. Like, you can tune it, kind of, but it's just so bad at staying in any position that it's really futile. Yeah, I don't know what the next steps are for this project. It's definitely turning out to be more complicated than I was expecting, just to get this to perform quite well enough. It's just so close, but it just keeps being so close, so I think there's just some breakthrough that I have yet to actually find that will help out. That one works. That one also just kind of bounces. What about pairs of motors? Those two kind of chatter and rotate. Those two work pretty well. What was that? That was this one and that one. This is, again, at the point where 2 directions are working really well and the third is annoyingly not quite. I'm about out of patience for this at the moment. What? Oh man. That's pretty great. I could do that for a while.